Uh, Hi, all welcome. Myself Naveenraj. In today's class, we are going to see about the combinational circuits. So, the combinational circuit is nothing but a circuit whose output only depends on the present input. Okay. Um, See, it does not require any feedback signal. So, under the combination circuit, the first topic we will going to see learn about the multiplexer. So, there are various applications in the communications in normal day-to-day communications. The multiplexer is using. So, before going to the deep about the applications of multiplexer, first we will study about what is multiplexer and how it works. Okay, so multiplexer is nothing but a combination circuit. It has 2 power n data and 2 power n data inputs and n selection lines, and it has only single output line. So 2 power n indicates number of bits. So it depends on number of bits, the data line inputs will be varied. So for example, if n is 2, that is 2 power 2, that means 4 inputs and 2 selection lines, that is A and B are the selection lines. So these selection lines used to select which input should be delivered to the output Q. Okay, there are many inputs. If many persons are calling to a single person at the same time, this multiplexer selection line will plays a vital role here. This helps to allocate which call should be delivered first, and that will be based on the selection line. Okay, so one of these data inputs will be connected to the output based on the values of selection line. So based on the values of selection line, for example, A, B, C, D, in the given picture, the A, B, C, D are the 4 calls at the same time, but which call should be connected to the queue, it will be decided by the selection line. So multiplexer is nothing but many inputs and single output, and with n selection lines. So based on the selection line, the input will be delivered to the output. So next, for example, if you take 4 cross 1 multiplexer, that means 4 inputs and one single output and 2 selection lines. So this is the logic diagram of the 4 cross 1 multiplexer. Next, this is the truth table of the 4:1 multiplexer. One of these 4 inputs will be connected to the output based on the combination of inputs present at these 2 selection lines. For example, if 0 selection lines are considered as S0 and S1, based on that output Y0 will be selected. For example, if both selection lines are 0, the input I0, the first input, will be connected with the final output Y. Okay, so if the selection lines is 0, 1, then the second input I1 will be connected to the output Y. Similarly, 1, 0 means the selection line will connect the I2 input to the output Y. Similarly, for the last condition will be 1, 1. This is for 2 bits. So if you go for more 3 bits, S0, S1 and S2, and you can start from 0, 0, 0 to 1, 1, 1 until number of inputs. Okay, so it depends. So if at this there are n number of peoples can call at the same time to the particular person. So it depends. Okay, based on the number of inputs and selection lines will be decided which input should be given to the output. We can also implement the above logic and diagram and truth table with the Boolean function using the inverters, AND gate and OR gates. And this is another example for 8 cross 1 multiplexer. So here 2 power n, that means 2 power 4, 2 power 3, that is 2 to the 4, 4 to the 8, 8 is to 1. So here you will be having 2 multiplexer, 2 4:1 multiplexer will be connected, and these 2 4:1 multiplexer is combined using one 2 cross 1 multiplexer. So selection lines, totally you will be having 3 selection lines. Let us see here S0, S1 and S2, you can see in the diagram. So two selection lines will be commonly act for two 4x1 multiplexer, and one selection line S2 will be acting as a selection line for the 2x1 multiplexer. So this is nothing but a cascading of 4x1 multiplexer with the help of one 2x1 multiplexer. You will be getting the 8x1 multiplexer. This is the truth table of the 8x1 multiplexer. The inputs varies from I0 to I7. So based on the selection line, different input will be delivered at the output, which is already we have seen in previous 4x1 multiplexer. If the selection line inputs are 0, 0, 0, I0 will be appeared at the output. If the selection lines are 1, 1, 1, I7 will be appeared at this output. Similarly, we can connect also 16:1 multiplexer. So if the number of users is increased, the communications, mobile communication will use this 16x1 multiplexer as the then for here in 16x1 multiplexer, two 8x1 multiplexer is combined using one 2x1 multiplexer. Here you will be having 4 selection lines, S0, S1, S2, S3. So that means 4 bits will decide which input should be connected at the time with the Y output. So similarly, the truth table for the 16:1 multiplexer is given as follows. Here the input varies from I0 to I15. So the 15 users here. So here the number of users has been increased. So definitely these multiplexers are used in communication, mobile communications. So based on the number of users, you can use your selection line to select which input should be connected. Okay, so others has to wait here. Because the selection line will select the input based on the values present at the selection lines. Then advantage, it reduces number of wires, circuit complexity and cost wise. You no need of any K maps here for simplification purpose, and we can implement this many combination circuits using this mux also. And there are some disadvantages also, which are delays in switching process, because others have to wait during the selection line will be connect only one input at the time with the output, so others has to be waited. Okay, so that is the major disadvantage of multiplexer. So this is why typical application of multiplexer you can see here. So there are so many inputs are here. So one is MP3 player, laptop, digital satellite, digital cable TV, so everything. So that surrounding sound system is connected with all these things. So based on which selection line is decided, the particular input will be connected with the sound system output. So this is the application of your multiplexer. So thank you all.